Hey guys, lesson 8, molecular formulas. This will be the last lesson of this unit. Our objectives are to determine the molecular formula from the empirical formula and molecular mass. So let's start page 24 of your notes, determining molecular formulas. So we're going to use our knowledge of empirical formulas to now determine the molecular formula. So far, we know how to find an empirical formula from percent mass. We also know how to find empirical formula from a molecular formula. Please review that from lesson 7 if you do not know how to do that. But how do we find out the molecular formula from an empirical formula? Okay, so remember, empirical formula is the smallest form of the formula. Okay, so everything's reduced. So here's an example. We have a compound that is 80% carbon and 20% hydrogen by mass. If its molecular mass is 75 grams, what is its empirical formula? And also, what is its molecular formula? So the steps are very similar, actually almost identical to determining empirical formulas. So first we must determine the empirical formula using the 3-step process. Step 1, assume a 100-gram sample and convert your percentages to grams. So this would be 80.0 grams, and we have 20.0 grams of hydrogen. Step 2, we're going to convert grams to moles because we have grams and we need moles. All right, so we have 80 grams of carbon, and there are 12 grams, about 12 grams of carbon in 1 mole, grams per mole. So that would be your GFM of carbon. Now when we divide this out, we get 6.66 moles of carbon. Remember, this is the abbreviation MOL. For hydrogen, we have 20.0 grams, and in 1 mole of hydrogen, we have 1.00794 grams of hydrogen. Punch that into our calculators, we get 19.8 moles of hydrogen. Okay, so step 3, again, divide each mole number by the smallest mole number and round to the nearest integer. So we'd have 6.66 divided by whichever is the smallest number, which would also be 6.66. This is for carbon, which is equal to 1. So the subscript on carbon is going to be 1. And then for hydrogen, we're going to have 19.8 moles divided by the lower number, 6.66, and we get 2.97, which rounds to 3. So our empirical formula is CH3. Remember, these are the subscripts on each element. Now we can determine the molecular formula. So the empirical mass is equal to the mass of 1 mole of CH3, which is going to calculate to 15 grams. Okay? Carbon is 12 and hydrogen is about 1. So we're going to round it and say a nice whole number of 15 grams. Molecular mass, they told us, was 75 grams. Okay, so the molecular mass is 5 times larger. If we do 75 divided by 15, it gives us 5. So that tells us that the molecular mass is 5 times larger than the empirical mass. So the molecular formula must be 5 times larger than the lowest form, the empirical formula. So we're going to multiply all subscripts in our empirical formula by 5. So we had CH3. So now we're going to multiply all of our subscripts by 5. So it will be C5H15 will be the molecular formula. Remember, not the reduced form. This is based on the molecular mass. All right, so let's do some practice, and then you'll do some on your own. So number 1 says, what is the molecular formula of a compound that has an empirical formula of NO2 and a molecular mass of 92.0 grams? So let's look at our steps, and we're not given percentages, so we're going to go straight to step 2. We have an empirical formula of NO2. So we need to know the empirical mass, okay, which is the nitrogen plus the 2 oxygens, okay, which is approximately equal to 14 plus 32. which gives us 46 grams. Okay, now we look and say, okay, the molecular mass is 92 grams. So how much larger is that than 46? And we can simply do this. Divide our molecular mass by the empirical mass. I'm going to abbreviate to give us our number to multiply by. So we have 46 grams here, 0.0, and when we divide that out, we get 2. So the molecular formula is 2 times larger. So we multiply that out. So this is going to equal, then we have NO2, multiply all the subscripts by 2, N2O4 will be your answer. Okay. Number 2, a compound is 50% sulfur and 50% oxygen by mass, and they give us a molecular mass, and we don't have the molecular formula, and we need to get the empirical formula as well. So we have to do 2 different things here, determine molecular formula and empirical formula based on percentages. So remember, this is step 1, percentages get converted to grams. So for sulfur, we have 50 grams divided by the atomic mass of sulfur, which is 32.06, which is grams per mole. Okay, and then let's go to our oxygen by mass. All right, 50% or 50 grams divided by 15.9994 grams. And when we calculate that, we're going to get 1.56 here. Okay, and for this one, 3.13 with sig figs. So next step, all right, step 2, actually step 3 now, because we did step 1 and 2. Step 3 is to divide by the lowest number, okay, the lowest mole number, which would be 1.56. This is going to give us our empirical formula. Then we can try to get the molecular formula based on the mass. So here is going to be 1, and then when we divide this out, we're going to get 2. Okay, so it's a 1-to-2 ratio, so our empirical formula is equal to SO2. All right, now we have to determine the molecular formula from its molecular mass. Well, let's get our empirical mass from the empirical formula. So it's S plus O2, which is equal to 64 grams. And how did I get that? It's sulfur, the mass of sulfur, 32.06, plus 2 times the 15.9994. And again, I rounded. So I get 64 grams for the empirical mass. Now the molecular mass is 128. So let's do 128 grams divided by 64. And this will tell us what we have to multiply our subscripts by. So 128 divided by 64 gives us 2. So 2 times greater. And our molecular formula will then be 2 times greater than the SO2. So S2O4. Okay? All right, so what I'd like you to do is 3 through 5 on your own after looking at my first 2 examples and going back to all the steps. Read what they're asking in the question. They may ask 2 parts. So you might have to get the molecular formula from the empirical and then vice versa, and then use the molecular mass to get the molecular formula, and so on. Okay, so please use those examples, guys, and have fun with that, okay?